that is series, and we had some random discussion in the beginning. We did not talk a lot about it. So let's directly practice and understand the concept through past paper questions. Okay, so do not consider it as a past paper question. I know that for now you guys are not clear with anything. Let's clear our concepts using these questions. Okay, the very first question says the coefficient of x cubed in the expansion of 1 minus px to the power 5 is minus 2160. Find the value of the constant p. And this is the paper. You can just note it down. Okay. Acha. Now, as I told you, this question is going to appear in the beginning. Question about expansion and all of that would come in the beginning. And is the examiner asking you to expand and find the first 4 terms or stuff like that? No. He's talking about some specific term. He's talking about the term that has x cubed in it. Okay. So this is what you need to understand. Every time for this first question, we have this one formula that you need to use to solve all different types of questions. And the formula is NCR A power n minus R B power R. This is the formula which we need to use. Okay. Now, how exactly do we use this formula? This is what we need to understand. If you remember, in the beginning of the last class, not in the beginning, like when we started off with the discussion of this chapter, I wrote NC0, A power n, B power 0, NC1, A power n minus 1, B power 1, and all of that. I wrote all of that using this formula, right? So I need to plug in R equals 0, NC0, A power n plus, now I'll plug in R equals 1 plus R equals 2. And here is that binomial expansion formula. So no need to memorize this formula, no need to remember this formula. When you have this, you can easily plug in. If the examiner is saying find first 5 terms, if you want to write this formula first, you will use R equals 0, R equals 1, R equals 2, R equals 3, R equals 4. Okay. So R is starting from 0, depends upon how many terms you need to find, and then you can write it down again and again. Okay. Achha, that was the first thing. The other thing. Now, when the examiner says the coefficient of x cubed in the expansion of this is minus 2160. So what do? We need to find the coefficient of x cubed and equate it to minus 2160, and that would give me the value of p. But this does not imply that first of all, I will start expanding it. I'll write down the first term, I'll write the second, third until I get x cubed. Yes, it might be possible for this case, but otherwise this would take a lot of time. And even if I start thinking about it, that which term would have x cubed, this would take a lot of time. Okay, so what do? We use this formula written in the yellow box. How do we use it? I'll tell you. So n is 5, n is the power. Okay, a is the first number, that is 1. B is this entire thing, that is minus px. Very good. And now what is R? R is something that I need to find. This is why I'm using this formula, just so I find R. And once I have R, I would be able to find the coefficient of x cubed in terms of p. Okay. So the formula would be 5CR. A is 1, A power, it's 5 minus R, and then B is minus px power R. Just like I told you guys yesterday, we did not write this formula to find the coefficient. We cannot do anything with 5CR and 1 to the power 5 minus R unless we have R. Okay. So sabse pehle to we are working for that. I need to extract the x term out from here. Okay. What is going to be the x term? It is going to be x power R. Okay. I only need the x term. what and with its power. So the power of x is going to be r, and I need to compare it with this term. Sorry. I need to compare x to the power r with this, okay? And why am I doing it? Because this is basically some term, okay? And I need to have the term that has x cubed. So I need to have that r. So what do? Whatever x term we are getting from this, I'm going to write it down here and I'm going to equate it to this x cubed, just so we get the exact term. So r is equal to 3. Okay, yeah, this is not the answer. This is something that we wanted in order to find the answer. Now I know that it would be the term having r equals 3. That is, which term would it be? Which term is going to have, yes,
Miss
very
4.
good. Very good. Okay. So now let's do it quickly using the same formula. Now I know that it's 5c3 1 power 5 minus 3 minus p x power 3, and this is going to give you 5c3 is, just press 5, then shift, then divide button, then 3 on your calculators. That is 10. That this is going to remain 1, and this is going to be minus p cubed and then x cubed. Okay, when negative is cubed, it would again remain negative, and this is going to give me minus 10 p cubed into x cubed and the coefficient of x cubed. This means that this entire thing is basically equal to minus 2160. Okay, the coefficient of x cubed, it does not have x cubed, so minus 10 p cubed is equal to minus 2160. Minus and minus would be cancelled, and p cubed is equal to 216. So p is going to be equal to 6. This was the question. Yes, now take a few seconds, and if you have any query, you can ask me. And you will see that all the questions that we will practice today are going to be question number 1, question number 1, question number 1, because this is going to be the first question, right? So you need to be really good at it, because this would help you gain confidence, and with that confidence, you would be able to do the remaining questions.
Miss, where did the x go in 10p cube?
This one?
There was also the x cube, yes, miss.
Okay, so this was basically, it said the coefficient of x cubed, right? So whatever we have written next to x cubed was basically minus 2160. So this means that whatever we have written next to x cubed is this thing. This thing is equal to 2160. That is why I did not write x cubed, because the coefficient of x cubed is minus 2160. Okay, when we will expand, it would show up like this. The fourth term is going to have minus 2160 x cubed. So this is what I would get. And so I compared this thing with this thing, right?
Okay, miss, got it.
Yes, Modusam and Munja, anything that you would like to ask?
Yeah, I'm okay, ma'am. Thank you.
No, ma'am.
Okay. All right, let's look at the next question. Okay, again, this is the first question. And this is the exam. You can just note this. All right. Okay. And it is question number 1. Okay. So it's a 3-mark question again, and it says, the term independent of x in the expansion of this, where k is a constant, is 540. Find the value of k. So the English says the term independent of x. So this means that it is going to be the first term? Not necessarily. Not necessarily. Yes, it could be the first term, but this time around we have x in both the terms, and in the second one, like b is k by x. So I'm not sure that where exactly I would get this term. And every time we won't be sure. We are not supposed to waste our time and think about it this way. So again, I am going to use this helping formula, that is NCR a power n minus r and then b power r. Okay, this is basically the formula which I need to use. Okay, what do I know? N is equal to 6. N is this power. A is the first thing that is written inside brackets, that is 2x, and b is k by x. What is r? This is why I'm using this formula. I need to find r. Okay, so 6 c r, a is 2x power 6 minus r, then b is k by x power r. I have told you guys time and again, this formula is only used to extract x. Let's extract the x that is coming from this term. It is going to give you x power 6 minus r, and this is going to give you 1 divided by x to the power r. Okay, now we will use basic indices rules, and we are going to just make things simple. I am going to take this x to the power r to the numerator. This would become x to the power 6 minus r minus r. Okay, this x to the power r is taken to the numerator. When we take things to numerator, let me do it stepwise if you guys have forgotten. This would become x power minus r. Now bases are same, and they're being multiplied, so I can write it as x to the power 6 minus r minus r, and this would give me x to the power 6 minus 2r. Now it says the term independent of x. This means that this is going to be 0. Only then I would have no x term, right? Like I would certainly have a term that is having x, but it says the term independent of x, like the constant term. So the constant term, what is important? The power of x is going to be 0, because when the power of x is 0, only then I would be getting 1 as x power 0, right? I would not be getting the x term. So x to the power 6 minus 2r is equal to x to the power 0. At this point, I need to equate this to this. And what am I going to get? 6 minus 2r is equal to 0. 6 is equal to 2r, and r is equal to 3. This is what I am going to get. Okay, so r is equal to 3. I'm not done yet. I'm supposed to plug in r equals 3 now, and the constant term is given. I'll equate it, and then this is going to give me the answer. Okay, acha. So 6 c 3 2x power 6 minus 3 k by x power 3. Use your calculators and see what is 6 C3. It's 20 multiplied by 2 power 6 minus 3, that would be 3. So that is going to give you 8. And x to the power 3 multiplied by k cube divided by x to the power 3. Now you guys can see yourself using r equals 3. I was able to cancel x cube with x cube. Then I am only getting the constant term. And finally, 20 multiplied by 8 is going to give you 160 k cubed. And this constant term is basically equal to 540. Okay. The term independent of x in the expansion of this, where k is a constant, is 540. So this is equal to 540. So k cubed is equal to, yes, please use your calculators and tell me your final answers. It's 540 divided by 160. And then the cube root of this. So
1.5.
yes,
3.2.
very good. 1.5 or 3 by 2, right? You're getting 3 by 2, so that is 1.5. Very good. So this was 27 by 8, and then k is going to be 3 by 2. So k is equal to 3 by 2. And this is your answer, okay? Now this time around, again, you can see we use the formula in order to find the specific value of r that would be containing our term. And then we got it correctly. Any confusions with this?
Miss, since the k is constant, shouldn't it be like both positive and negative? Because when we will apply the cubic root on 27 divided by 8, we will have plus minus.
No, we
Cube
don't
root
we
of
don't we don't get plus minus once we have the cubic root, right? Like we get plus minus once we have the square root or any root that is to the power 4. When I have minus 1 multiplied by minus 1 multiplied by minus 1, this is going to give me minus 1. But when I have minus 1 multiplied by minus 1, this gives me 1. So things are uncertain in case of squared. Like at that point, we write down with plus minus. But whenever you have cube root, we don't write it down with the plus and minus sign. Okay, that is certain.
Okay.
And how exactly it is coming from, or where exactly it is coming from? Whenever you have 3 terms that have negative sign, when you multiply the 3 terms, you again get a negative sign. So for example, and even you can have a negative number in case of cube root. So if you do cube root of minus 8, you are going to get minus 2, right? So for cube root, things are different. For square root, it's different. Okay.
Okay, miss. So like all the even numbers will have plus minus the constant.
Yes. Squared, then to the power 4, to the power 6. Yes.
Okay.
Okay, perfect. Acha, let's talk about the second question. I'll explain the question. In fact, I'll do the question, then I'll ask you guys to do the last one. It says for this value of k, find the coefficient of x squared in the expansion. Okay. So it is 2x plus 1.5 divided by x to the power 6. The question was for this value of k, we got k equals 1.5. Find the coefficient of x squared in the expansion. Okay. Now, one thing is clear that, again, I will not just guess that the third term would be having x squared. I'm not sure about it, okay? Because I don't have a simple question. I have x in both a and b, and then b x is in the denominator. Again, I'm going to use the formula. So it is going to be 6 CR. A is 6 minus R. B is R. I'm going to extract X only. So this is going, in fact, we did all of this for the previous part, right? So what you can do is, instead of doing it this way, we again, the only difference in this and the new part is that here we did not have the value of k, but that is irrelevant. At the end, we are extracting x only. And this was the final thing. X to the power 6 minus 2r. Okay. So after doing all of this working, I would get x to the power 6 minus 2r, and this time I need to equate it to x to the power, yes,
2. X to the power 2.
very good, because the coefficient was x squared. So I'll compare 6 minus 2r equals 2. I'll take this over here. So 6 minus 2 equals 2r. 4 equals to r, and r is equal to 2. Okay, r is equal to 2. This means that the third term has x squared. Okay, and this thing is very, very important. This working is important to be certain. And now I can directly just plug in the values. 6c2 2 power 6 minus 2 and 1.5 power 2. Now I did not write the x terms because that is irrelevant. I only need the coefficient of x squared. And upon simplification, I would get 6c2 is 15 multiplied by 2 power 4 multiplied by 1.5 squared. And this is going to give you 540. 1 second. Yes, this is going to give you 540. This is the correct answer. Okay. Now here the constant term was 540. Okay, that is fine. And here the term that would be having x squared, like the coefficient of term having x squared is also 540, right? And this answer is correct. So any difficulties with the working? And this was for 2 marks only. Why? Because you were supposed to use the previous part for this part. Like we have already made this formula for the previous part, just use that and then you would be able to do it correctly.
Okay.
Yes.
Yes,
Why did you not plug in x?
because it said find the coefficient of x squared. Okay, so if I write down a random expression, what is the coefficient of x? It's 5. The
5 here,
coefficient,
6.
yes. So these are the coefficients. Okay, that is why I did not include x squared here. I did not even, you can certainly write down the x terms. It's not wrong. You can write it down. But at the end, the final answer has to be 540. And in the marking scheme, the examiner has also given 540 x squared. That's also fine. But if it says find the coefficient of x squared, you're only supposed to write down the number. Okay, but if by mistake you write down 540 x squared, that would also be accepted.
Miss, can you go to the first question?
Yes, definitely. This one or the one before it?
Yeah, this one. Miss, the part that I did not understand here, the term independent of x, this part did not understand. And the other part is x6 to the power of 6 minus 2r is equal to x0. This part I did not understand.
Okay. I'll tell you. Okay, 1 second. Very good. Okay, both parts are linked. This basically said the term independent of x in the expansion. Now you know that when we expand, for example, if let's say if I have 2 plus x whole squared, so when I expand, this is 2 squared plus 2 into 2 into x plus x squared. This is what I get. Okay, so which term is independent of x? This first one. Why is it independent of x? Because I have x here, I have x here, and I do not have x here. So this English, like whenever the examiner would write it down this way, the term independent of x, this would basically mean the constant term, okay? The constant term. So when exactly is a term constant? A term is constant when it does not have x, okay? This was my formula, and after doing some working, I got this, okay? Now the term has to be constant. This means I do not want x in the term. So I cannot write x power 1 or x power 2 or x power 3 because I do not need x. I just wanted a constant term. That is why for such cases, we need to equate it to x power 0. So you can also think about it this way, that whenever it are talking about the independent term, we would be equating it to x power 0, because x power 0 would basically mean 1, right? 0
Yes.
in the power for any number is 1. So this would give you the constant term. Okay?
Okay.
Sure?
Yeah, miss.
Okay. All right. Perfect. So all right. This is the first question of another exam. And here's the paper. And Munja, you can leave whenever you have to. Okay, that's not an issue.
Okay, thank you.
You're welcome. Okay, so this is the paper code and everything. You can just note it down. And here is the question. Okay. Now it says expand 1 plus y to the power 6 in ascending powers of y as far as the term in y squared. Okay, let's understand this first. Okay. So expand 1 plus 6 in ascending powers of y. This means that the first term would be a constant term, then y squared, y cubed, stuff like that. As far as the term in y squared. So we need to stop when we get y squared. That is it. Okay. So for such cases, we are not supposed to look for a specific r. We need to start plugging in r equals 0, r equals 1, r equals 2, r equals 3, and then see what exactly happens. So the formula is NCR a power n minus r b power r. Okay, so n is 6. 6 c 0 1 power 6 plus 6 c 1 1 power 5 and y power 1, then 6 c2 1 power 4 and y power squared, and I can see that I had to stop at this point and I already got this. Okay, so just use your calculators in order to find the values. 6c0, always remember any number, like if you have xc0, yc0, tc0, that is going to be 1. Okay, so you can also use your calculators, but it's going to be 1. Then 6c1, that is going to give you 6 plus 6c2, and that is going to give you, 1 second, this is y, and then this is 15y squared. So this is going to be the answer. Okay, we did not spend a lot of time in thinking about which r to be used. You were only supposed to use r equals 0, 1, 2, and we got the expansion. Okay, so I hope that this part would be clear. Acha, let's talk about the third part, the second part of the question. It's for 3 marks. It says, in the expansion of 1 plus px minus 2x squared. Now this is my a, and this right here is basically my b. The coefficient of x squared is 48. Find the value of the positive constant p. Okay. Again, the question is not difficult. A and B are a bit different. We have n as 6 and the coefficient of x squared is 48. Okay. You need to find the value of the positive constant b. So I am going to give you 2 minutes try doing it, and then if anyone is not able to do it, then I'll do it. Okay. Yes. Are you guys able to do it? Motasam and Rafe?
Just wait a second.
Okay, okay, sure.
I'm solving this.
Okay, okay, sure, sure.
Miss, I'm not able to make the
Mm-hmm. The R
Because I'm not
thing?
able to find R, yes.
Okay, yes, I know. I know this thing. Okay. Acha, okay. So this is the question. Let's try doing it in the same way. This tarabi we have discussed. It is N C R, and then we have A power N minus R, and then we have B power R. Okay. So N is basically 6, C R 1 power 6 minus R, and then it is px minus 2x squared power r. Okay, let me write it down. Now it is px minus 2x squared power r, and this thing is the x term, right? This is the x term. So after extracting the x term from this part, like this was the x term, after extracting it, this is what I got. And now this should be equal to x squared. Now I can only make comparisons once I have something of that type, as in here this is px, we have minus 2x squared. Even if we take x common, nothing is going to happen. Still we would have p minus 2x. We want 1x on this side, right? We want 1x on this side. Even if we try applying the completing square method, even then I would get a bracket with something and something and to the power r. Still I would not be able to make comparisons. Okay, so that is the issue basically. One second. Okay, all right. So this means that we were not able to do it this way. Okay, another way. Another way, and the issue was coming because of the unknown r, right? I don't know how do I expand this. Like I would have expanded this if r was 1, if r was 0, if r was 2, if r was 3, but since this r is unknown, I am just stuck at this point and I'm clueless. And for such cases, one thing is certain, that r would not be too high. So what you can do is you can just start the expansion from the beginning, just so you have some known r's, and then you can start checking it out. Okay, so let's do it that way. Or another way could be that if we start taking r's at this point, okay, one way is that you start expanding the thing from the beginning. Another way is that if you take r equals 0, r equals 3, and stuff like that, then you can also make comparisons. Okay, so if we take r equals 0, this entire thing is basically going to become 1, and we would not have x term. Okay, so that is not the case. If we take r equals 1, what would happen? I would have px minus 2x squared, and still this is not going to work well, right? This is not going to work well because this is equal to x squared, and at this point I am not sure how exactly do I compare both the terms. So let's try doing it for r equals 2. Okay, now when I will take r equals 2, what would happen? Let's see. It is basically going to be 6 c2 1 power 6 minus 2. I'm writing the entire thing for a purpose. px minus 2x squared whole power 2. This is what I would have. Okay, so 6c2 is going to give you 15. And then this part is px minus 2x squared whole squared. Okay, and now let's try playing with this and let's see if we are able to do something out of it or not. Okay, this is 15 when I am going to expand this part, I am going to get p squared, x squared, then we have minus 2 multiplied by the first term and then the second term, and finally 2x squared to the power 2. This is what we are going to get. Okay, first term would be squared, then we would have minus 2 into this term and that term plus the square of the last term. Okay, this is 15 p squared x squared minus 4 px cubed plus 4 x squared okay. Again, the issue is that when we have x squared, x cubed, and x squared, like if we had these two terms, we would have easily done something about it, right? But
Okay.
because of, yes,
Miss, won't it be like 4x to the power 4?
4x to where? Wait, one sec. Where exactly? 4x to the power 4. Yes, 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 yes. That is right. That's right. Yes. This is going to come with 4 as the power. That is right. Sorry. I'm just trying to figure out something at this point. Just give me 1 second. They have expanded the entire thing. 1 second. This was the term with x squared. What they have done is they have expanded the entire thing with r equals 0, r equals 1, r equals 2, and then they have cancelled terms in between. This is what they have done. Okay. The first term is going to be 1. 6c0 and then 1 power 6 and then px minus 2x squared power 0. This is going to be the first term. For the second term, it would be 6c1, 1 power 5 and then px minus 2x squared would come as it is. And then the third term is basically going to be 15 px minus 2x squared whole squared. Okay, so this is going to be my first term. This is what I was talking about instead of using the R formula, since it did not work. We can write it down this way. And next, let's try simplifying it over here. Okay. Yes, so this is going to be 1 plus 61 would give you 6. 1 power 5 is 1 and then px minus 2x squared plus 15 into px minus 2x squared power squared And then you need to just simplify things at this point and then make conclusions, okay? So this is basically the thing at this point, okay? This would be 1 plus 6px minus 12x squared. Just give me one to 2 more minutes, okay? Yeah, just 2 more minutes. Plus 15px. 1 second. I need to expand this first. Px squared minus 2 into px into 2x squared plus 2x squared power 2. 1 plus 6px minus 12x squared plus 15p squared x squared minus 4. Again, the same thing is coming. Minus 4p x cubed. This would be multiplied by 15. So this would become 60. And then minus 4 into 15 again is going to give you 60x to the power 4. Okay. 1 plus 6px. Yes, exactly. 1 plus 6px minus, I'll take x squared common, 12 plus 12 minus 15p squared. And then that is irrelevant because we have x cubed term and x to the power 4 term, okay? And at this point, I got the coefficient of x squared minus 12 minus into 12 minus 15p squared, and I can write it as 15p squared minus 12. This is the coefficient of x squared, and now I need to equate it to 48. And after making p the subject, it would become 15p squared equals 48 plus 12. P squared is equal to 60 divided by 15. And this would give you p equals plus minus 2, but they have mentioned that p is a positive number. Okay, so just give me 1 minute. I'll tell you what happened and why was this question comparatively complicated. Always remember, whenever you would have a or b of this type, okay, you are not supposed to use the R formula directly. Why? Because when we do not have the value of R, we would not be able to make conclusions. The best possible way is start expanding from the beginning. This was the first term, this was the second term, this was the third term. And after multiplying, making things simple, this was the constant term with x, term with x squared, term with x squared. And after finding the exact term with x squared, that turned out to be 15p squared minus 12. I equated this term to 48 and I got p equals 2. This is the difference in this question and the previous questions that we have done. Yes, are we clear with this?
Miss, when we took the x from the entire formula, like px minus 2x squared all to the power of r is equal to x squared, and that didn't work, then what is the second method actually?
Yes.
Like,
1 second. So first of all, you plugged in the formula and you wanted to compare, and that did not work. Then we just used r equals 0 in the formula, r equals 1, r equals 2, and even that did not make any sense, right? So the best possible ways, this is what I was saying. For such scenarios, when you have this thing, just start expanding from the beginning. Because by now you guys have noticed that either the r is 2 or the r is 3 or the r is 4. So we can expand to the first 4-5 terms. That is fine if you have this case, okay? So this is basically the thing that you need to do, because they said coefficient of x squared, and that is only possible when we have all the coefficients written. And then once we, are able to see that this is the constant term, x squared terms, x cubed term, x4 term, this is the point that is going to help us find the value of p. So you need to expand from the beginning, okay? This is the difference.
Okay, miss.
Yes, Mudasam, were you able to understand this?
Miss, did you use the completing square method here?
No. I have just used the same formula. Look at this, the same formula with 0, 1, and what happened? This was x6c2, I suppose. Yes, I did not write it down, but I've just used the same formula and I've expanded the entire thing. And this is what I got after this is what I got. And then I just, multiplied 6 and multiplied 15 and I got this. And at this point, I was able to see the constant term, the term with x, the term with x squared, the term with x cubed, and the term with x power 4. And here I was able to find out the exact coefficient of x squared in terms of p. That was 15p squared minus 12. I compared it to the coefficient that was given, that is 48, and I got p equals 2. Okay. So the difference in this question and in the previous questions is that I did not try finding out r like we did. We tried finding out r, but we were not able to find r because of this difference, right? Whenever you have px minus 2x squared, something of this type, just know that you are supposed to expand the entire thing. Okay, and then certainly you guys would be, just look at it. We only expanded it to the first 3 terms and we were able to find the answer. Okay, so just try expand.
Miss, the number of expansions that we should do is like here, like for example, we did 3 here, for example. And Miss, is that just a guess, or you should know when to do like 4 expansions or 3 expansions?
Yes, if the examiner has mentioned, like either the examiner would say expand to the first 4 terms, or he would write it down this way, expand in ascending order as far as the term in y squared. So he would give you clues. But for this case, he did not mention, he did not want you guys to expand and tell all the terms. The question was something else. So for this case, yes, you can try expanding to the first 3 terms. And if that does not work, just find the 4th term as well. Okay. For this question where exactly he is not asking you to expand, you can certainly do it this way, that just try doing it for the first 3 terms and then do it for another term. But otherwise, whenever he wants you to expand, he would certainly mention that. Okay.
Okay, Miss, just another part, Miss, at the end, when you say x squared 12 minus 15p squared, here, Miss, how did you know that this one was the correct one, like to get the answer for p?
This part, okay, why did I stop here? Because it was mentioned that the coefficient of x squared, this is x squared, right? So I just made x squared the subject just so I can find the coefficient of x squared. And that turned out to be minus, and then this thing, and after simplification, this was 15p squared minus 12. This x squared was given in the question.
So, Miss, you know that after we expanded everything, and at the end it gave us x squared, right?
Yes. Because if the question was about x cubed, I would have considered minus 60p. If it was about x to the power 4, I would have considered this. But it says x squared. So that is why I just considered this part. Okay.
Oh, Miss, so you factorize it, yeah?
Yes, I've just taken x squared common. Yes, I factorized it. You are right.
Okay.
Any other thing?
No, Miss.
Miss, is there any other formula for these type of questions?
What type of form? Like the 6CR form, like NCR, other than that?
No, Miss, like any other method for solving this question?
Yes,
like
yes, I'll tell you. So whenever the question is about expansion only, like if the examiner wants you to expand only to find the first, second, third, fourth, fifth term, there we have a method that is called Pascal's triangle method, right? But that method is not very good, because using that method, you are only supposed, like that would only help you for the expansion, for the entire expansion. If you have been asked about some specific term for that, you would have to use the NCR thing. But we do have another formula that is basically called called Pascal's triangle method. And it is fine as far as simple expansion is concerned, but you won't be having any R there and, stuff like that.
Okay, Miss. Miss, are you going to take like any test of the
Yes,
previous chapter?
I will take. I will certainly take. I'll take. Okay, I'll message on group and I'll then talk about it. Okay.
Okay.
All right. Okay. So any other thing?